So this is about part 4 of the final test exam. So basically this is question number 15. Basically what it is, for the field response, the question would be incorporating between the concept of conservation of energy right here. But this one is pretty easy. It tells you that the ball is actually traveling along the incline. Translation only at this point. For the second semester, we're gonna have a rotational motion, which is a little bit more complicated, which I will introduce the equation later. So when the object is right here, right, it travels horizontally with that velocity, which is constant. So you need to know that I'm just gonna say it's at constant. So you know the height, and which is, by the way, is equal to the delta y for the kinematic motions. So we're gonna have to apply this equation. VO y. So we know the height, which is delta y. Velocity in the x direction or y direction, however, is 0 because there's motion which is per going up and down or in the y plane. Gt squared. So you're solving for t, pretty easy. So that would be I'm going to replace delta y with delta h divided by g square root of that. So that should give me my time. And then solve for delta x, which is how far from the basement where it lands. Vox t plus 1/2 gt squared. Since the velocity in x direction is constant, that term is 0. So what is our Vox? Vox is v. Our time is actually so that's your displacement in the x directions. So let's look back at question number 17, which is very similar to this one. So 17, you have where it lands to where it drops is about 3 meters. So that's your delta x is equal to 3 meters. Delta y is equal to 10 meters. That's the height. So you're gonna have to look back at what you get. And you're looking at this velocity when it is actually coming before it actually lands. So let's do backwards. Do we know the time? Because right now we know the x right here, the displacement in the x direction. We need to know the time in order for us to figure out what the initial Vox is. But since we don't know the time, let's go back to this equation. Voy plus t plus 1/2 gt squared, right? That's 10. Remember, this is 0 because there's no movement in the y direction on the y plane. 1/2. I'm just gonna put t there. Here. 5. T squared 10. 10 divided by 5. T squared. So that would be 2. So t by itself is x square root 2. So the time it takes for the object to travel from here to here is actually 2 square root 2. Now we can go back to this equation to figure out what the initial velocity of x is by using this equation. You know this. Displacement is 3. Vox, that's what you're looking for. Square root 2. So to solve for Vox, so isolate that one by itself. Vox is equal to that. So that is actually initial velocity in the x direction. And now let's look at the last question. Question number 16. So we may not be able to utilize the equation that we have here because the situation is a little bit different. So basically we've utilized only the last equation. So we need, for kinematic, we have this, and we have this, and we have that. This is the one we just did. So we've been using this. So this equation, it says a ball is thrown horizontally off a cliff which is 10 meters height. With initial velocity, which initial speed, which is 25 meters per second. What is magnitude of its velocity when it hits the ground? So if we figure out whatever it is right here when it hits the ground, so this question is a little bit tricky because you're gonna have to combine between Vox and Voy. So that is your magnitude of the velocity when it hits the ground. So you have to do those things. So first, you know the height. So instead of the height, I'm just going to say delta y. Okay, let's look at this equation. We don't know time, so we could use this equation. Or we could use this equation because we're given the height, which is much easier. So I'm just gonna go ahead and do that. 2g delta y, right? That's what we're looking for. 0. So it will be 2, 10, 10. Because when I replace this equation, the gravity is 10, the height is 10. Now I square root of that. Oh, I can do that one later because I know over there. So to find the magnitude of the speed, which is Vox, which is 25 square plus 200. Let's do it this way. 25 square plus 200. So when you do it this way, velocity is equal to square root first 825, and then when you do that, it's equal to 25. That's what you will get. And that's how you resolve question 16. So I want you to hear this music, so that's why I'm gonna keep explaining what kinematic equation is. So basically there are three different equations that you can utilize to solve for any physics problems, especially in the second semester of the exam, since kinematics is the first topic that we've we've learned. But then, however, in the system itself, it actually comes to play almost at the very last part of the problem solving. Why? Because in order for subject to be moving, we have to have some other forces, which is Newton's law of motion. Always need to have some kind of energy in order for that to be kicking, to be exerting the force, which by far will generate the accelerations. So when you have the acceleration, when you have displacement, you could utilize the concept of those concepts to figure out what the velocity is. So basically, kinematic is one of the most important questions or equations or topics.